On today's edition of Pipeline Things, thank you for joining us. We introduce you to two new guests, 3.0, who you will hear about in a moment, and our esteemed guest, who I'm actually not going to name. I'm just going to read some of his more fiery comments, actually just great discussion points. He says, science is about truth. Engineering is about compromise.
Fantastic.
Think about what that might mean as it relates to ILI technology. And perhaps a better one, I like this one, it is statistically impossible for all ILI tools to have the same statistical performance.
And my favorite of the episode was, you cannot be foolproof for a sufficiently talented fool. Think about that one.
Oh boy, I think it's a great episode. It's a lot of fun. Stick around. Hope you enjoy it. Thanks for joining us. All right, welcome to today's edition of Pipeline Things. I am your host, Rhett Dotson, my co-host, Christopher De Leon, and we are really excited to be with you as we continue this Sage series. I personally kind of prefer the name OG, but that's okay. We'll go with Sage for today. Chris, today's segue is all about deja vu.
Oh, man.
And I feel like
history repeats itself. I mean,
history does repeat itself. And you know, one of our favorite friends says the only thing we learn from history is that we don't learn from history.
It. You know, and unfortunately, you get invested in things, right? And like you kind of get a momentum and rhythm. But one thing that is guaranteed is what? Change. And you got to get used to it.
So we got to catch the audience up. So last time that we filmed around PPIM, and just time state, you guys will listen to this in like May or June, but it's PPIM time right now. Was the first moment that the original Miss Producer got sick.
Yeah.
And second string Sarah
came through,
got her name, came on board, and
showed
filmed at
up
PPIM.
clutch.
This year we're filming live at PPIM.
And where's second
Trip S?
String Sarah?
Trip S is sick.
I'm looking and I don't see her.
We have the backup off the bench again coming through. The new, this is like Miss Producer 3?
Yeah, this is the
Miss Producer version 3.0.
Do you think it's us?
That's her name. We'll call her 3.0.
Do you think it's us? Yeah, that's actually a good one.
Yeah, all right. So I told you it would come to me on the show.
Morgan 3.0.
So we have 3.0. That will be our new producer. And the question is, will she replace Trip S? Is this the beginning of the end for Trip S?
We need to self-reflect. I don't. Do you think this is us?
Are we the cause?
Yeah. Do you think it's us? Do you think after about a year they're just like, I need to move on?
They get sick at PPIM because they're like, yeah, it's time. This is how I'm going to fame this.
Watch ADV Marketing give us guys. We have to have a meeting about you guys. We're gonna have to rethink how we.
But
we manage your account.
To the audience, you have 3.0 filming us now. We welcome her on board. I'm sure she's going to do a great job. But that's actually today's episode. I am really excited. We're bringing on another well-known sage. Fun fact about this sage, both you and I have sat in courses on this sage. Probably, if anybody who's anybody in the inline inspection integrity industry has probably sat in a course from this individual.
Yeah, both operators, consultants, and ILI service providers. And obviously when we were thinking about this series, the idea is, there's a lot of things that we can learn from past publications, but even more so people.
Yep.
And maybe even during COVID, we lost a lot of our network. And so we were like, this makes a lot of sense to bring in some of the OGs, some of our sages to just talk about hot topics. And, in thinking about it, I was like, we do ILI. And we know what the stepbrother or the middle child is of the ILI platform, but what's the OG ILI technology?
The firstborn of ILI?
Well, the firstborn is probably a caliper tool, but what's the favorite child?
Oh yeah, MFL. MFL is definitely the favorite child.
And so it has to be. It has to be, right? The magnetic principle, I feel like, is the favorite, right? And so I was like, God, we need to talk about this. We already talked about regulation.
So is that EMAT the baby child? Oh my God.
The baby. Is EMAT the baby? Gets to do whatever it wants, doesn't follow the rules.
Oh my God, that's so great. Oh man, to our audience.
I wonder if he can talk about EMAT too. I bet you he can.
Oh, you know what? Let's bring him on. The original sage related to MFL, Mr. Bruce Nestleroth, is actually our guest today. Bruce, come on.
Bruce, welcome. Thank you.
Thank you for joining us as we talk about the we said not firstborn, but the original, the
child.
favorite child of
That's a good way
Island
to
technology.
describe it. Yeah, there's cleaning pigs, there were caliper pigs, but yeah, it's.
I don't want to give the family designation for cleaning pigs. Let's.
That uncle.
Well, Bruce, thank you for joining us on Pipeline Things. I know I will say you gave us the most robust notes. We have so much good stuff to talk about today. I can't wait to get into it. But before we do that, will you please introduce yourself to the audience? Tell us who is Bruce Nestleroth?
Yeah, Bruce Nestleroth. I've been in the pipeline business for over 35 years. I'm a non-destructive testing person by training. I started my career in ultrasonics, looking for small defects in aircraft parts. I mean, when I got into the pipeline business, it was like, hey, you're looking for defects like corrosion defects the size of your hand. How hard can this be?
Can I make a career out of this? Yeah.
Didn't care if I made a career out of it. I just, it'd be a good project for a couple of years.
A couple of years, it'll keep you busy, huh?
Keep me busy, keep me out of trouble. Give me, I was working for, a place where billable hours, and looked like I could get a whole lot out of this. I could milk it pretty good.
Yeah. And so where was that? Tell us a little bit. Where did you cut your teeth on the pipeline industry?
I got started at Battelle. I always tell the story that Battelle's that place where B31G got its traction. RSTRENG, the log secant equation, the drop weight tear test, and how Sharpie energy got all that stuff. It was a place where a lot of stuff on pipelines got developed.
So, Bruce, I got a question. One of the first questions is people might not always remember organizations, but they remember people.
Yeah.
Anybody of relevance that may have worked with you at Battelle?
Because I kind of take a step back there, because Battelle probably, I doubt that anybody really even in the pipeline industry, you're coming up today, you don't even know Battelle. Because Battelle's not really in the pipeline business anymore. That's not, they're kind of a, have a tough problem, solve the problem, move on. They don't do things. I always give my favorite example is the Xerox process. They didn't
the Xerox machine.
Xerox machines.
Like you got a piece of paper, I need copies of it.
Yeah.
Okay.
What they did is, Chester Carlson, he was the guy who developed this way of electrostatically transferring stuff. I don't know. He had the patents, but he couldn't figure out how to make it work in a commercial environment. And so that's what Battelle did. Worked on the materials and processes and things like that. When it all got done, nobody knows who Battelle even worked on the Xerox process. Pipeline industry was quite the same thing. When it got started, there were issues with at the time when Battelle got into the pipeline industry, all they could do is if you had a corroded pipe and you lost 20% of the wall thickness, you just did Barlow's equation for 20% less wall thickness. That's all you could do. That was what the regulations said. And John Kiefner, he was, he asked for names. So
John, we know John.
John was, and Bill Maxey was the other guy.
Yeah.
Bill Maxey's not quite as famous because he never made his own company, I guess. But Bill, I think, was definitely part of that team that was working through there. And they were the ones who figured out that you mean we don't have to just go reduce the wall thickness? It can absorb a bit of a defect in there.
Sure.
The area equations that they came up with, they work fine. So that's kind of how they did things. And then cracking became a problem, and they worked through. We have to worry about toughness. Well, they came up with great practical ways of not dealing with the hard parts of tough. We'll do a Sharpie energy. That's going to be good enough. We can make something practical, and we can make it move on. And they come up with these fairly simple, easy to use equations, and still serve it. You still use those equations, don't you?
Yep. And it's funny, you mentioned Kiefner and Maxey, and those are only two names, right? But I want the audience to appreciate the depth that you guys had on the bench there, right? I'm going to read the names, so you don't have to, right? Because you gave us like you mentioned, Bob Eber, Brian Lease, Tom Bubenick. Those guys are still in the industry, still very well recognized. Mike Rosenfeld, Pat Veith. You were like
those are the young guys that I started with, and they're still.
But you were on like the all-star cast of pipelines.
Ray Fessler and Neil Thompson and John Beavers, and these are all guys that when we work out of Columbus, Ohio, and that's people kind of look at that as why is that's where Battelle started, but now you got DMV's up in Columbus, Ohio, and Keithner is up in there. Rosen has a shop.
We opened an office at our time back in Columbus as well.
And there's Gary Wilkowski, and he's a guy who really understands new pipeline construction. Something I know him only because I played soccer with him. Me and Brian Lease
Did not know you were a football fan. This is no. Chris gets very upset about football. No. So I'm. What was the first project that you worked on whenever you got pulled into the pipeline industry?
Curious to know why you're still in this. What was it that you started on?
What project were you going to finish in 1 or 2 months and then move on?
MFL. Yeah, I mean, it was Bob Iver, one of the names you mentioned there. He had this project that was basically trying to understand these pigs. ILI wasn't a term when I got started. It was pigs, and I still revert back to it. I know I'm supposed to call them that, and I also call them inline inspection vendors, and I know their service providers have a hard time saying those words. Just sometimes the old terminology. So Bob came to me and he goes, they have these, non-destructive testing, and I was in the non-destructive testing group at Battelle. I wasn't in the pipeline.
Because of your ultrasonic background,
right? My ultrasonic background. I got hired in, and they wanted me to. They said, well, can you figure out, how these tools actually work and what's going on? Because they sometimes they work well, and sometimes they just give you garbage, and we went through that. And, that short, it was a 6-month project. It wasn't a 2-month. It was going to be that evolved into a couple of year project where I just kept had these projects, and it was that was to do this, and we wrote about a 100-page report on what goes on there. And this was basically, at the time, there was a lot of, if the tool didn't work, there was a lot of fibs going on, and because they didn't really understand what was going on with why these tools worked and didn't. I came up and said, well, if the defect's narrow, it's not going to, that was not, well known then. They kind of just thought it was just if it ran into the defect, they get there. No, the flux goes around the defect. That was a monumental
groundbreaking back then, huh?
Small little pits and pinholes, all that kind of stuff. And it was basically the preface for that POF equation or diagram that
the POF diagram,
that everybody uses now that describes, you can do well in this type and there.
Dimension classes.
Everything goes there. So that was, I wrote this report, and the odd thing about this report is that I still get requests for it today.
And you brought us one.
You brought us a copy, right?
I do not have copyright.
We have a request. If you could get us a copy
of the original GRI, Battelle, MFL, Bruce Nestleroth.
Before I left Keithner, somebody borrowed my copy, and I didn't even get a chance to leave with it. And
they probably wrote their name in it by now, like you would do back in school.
I feel like that should be like, the ASME Red Book on pipe background. There should be an ASME book on the MFL report, But that's the gift that keeps on giving, right? You're still teaching people about MFL today, correct?
I still do, and some of the graphs date back to there. I've updated it since then and try to include more modern stuff. The basic principle is still the basic principle. It has good strengths. It's a good, solid, rugged technology that can withstand the pipeline environment.
The torture of pipelines.
It's not easy to get through a pipeline. That was the first thing that I had to learn when I started at Battelle. And I said, find defects the size of your hand. Well, that wasn't the problem. The problem is find defects the size of your hand and make it another 150 miles with that information. It's like, and don't lose it. That's a lot of effort, and don't have things break. Get all the way through there. So
I'm a little bit curious. You said that was a research project, right?
Yeah.
Talk to us a little bit about the research, right? Like, what was the goal of it? What were you guys? What were maybe the highlight takeaways from it at the highest level?
We wanted we built algorithms to try to understand, what is the true sensitivity of length, width, and depth on an MFL signal. We build algorithms and
So the physic component to
the
it,
physics.
right?
Yes.
How does, if you have a magnetic circuit
Yeah.
and a electromagnetic material or a piece of steel that can conduct the magnetic waves,
Yeah.
how does that operate, and what is the impact of the magnetic flux to certain type
And
defects?
you put a defect in the way. How does it get there? And at the time, it was just the time when computers were getting fairly decent, and you could do finite element modeling. This was a miracle at the time. It was easy. It was not easy. I mean, it was put in a defect, go home, come back the next morning, the finite element model ran.
Hopefully it finished and it didn't mess up.
Didn't have a power outage. Somebody didn't turn off the computer, or something didn't happen, and repeat. And we did this for months on end. But things we also did was we modeled velocity effects. And all the pipe, or if you start to get crud under your sensors, you move your sensors down a little bit,
So does standoff matter? Does velocity matter?
Velocity matter. All the inspection.
What about MFL sensor orientations? Or
Well,
anything like that?
up until then, everybody thought the magnetic field was just a single component. No, it is a vector quantity. We know that, but 3 axes are, that was miraculous, that was, oh, wow.
So when you feeding off of that, when we did the show prep, one of the things that you said, and I'm going to quote it because I think it's good, and I think it relates to this, is you said science is about truth, engineering is about compromise.
Well,
and how does that relate to ILI?
Well, that's, I use this in my workshop all the time because, if you just went through and you designed something, well, first of all, you want to use magnetic flux leakage because, that's not the technology you're going to want to do to measure wall thickness. You're going to want to do something, ultrasonics is probably the most accurate approach to doing that, but that's not going to work in the natural gas pipeline. So here we are, you got your first compromise. Well, and everything like that. And when you start to go build your tool, as I said, you want to not only record the data from that defect the size of your hand, you got to make it to the other end of your pipeline with that. Well, even to make sure the sensors survive, you do not. The best thing to do is have that sensor within a micro inch of the surface of the pipe. Well, that ain't gonna. That sensor's not gonna survive. You have to put it, a good fixed distance away from there, and so it's gonna blur the image. So you're not getting the best data. But again, the object is to get through the line and get good enough data. And so you have all these engineering compromises. And
Doesn't do you any good. You can collect the best data, but if the tool doesn't make it to the end of the line, doesn't matter how good the data was.
If you only inspect 75% of the line, that's a failed run.
Yeah.
That doesn't do
In some cases, if you lose a sensor or two, that's a fail.
Sometimes
Depends how corroded the line is, right?
Right. You can get in trouble. So you want to make sure that you get one, and that's. I still think it's miraculous that ILI tools can work for those distances, and that with that kind of reliability that they have. And it's people think it's not great reliability. It's usually like a 94 or 95% reliability, which wow, it fails 6% of the time. But I think that's still pretty darn good. No other industry has that kind of inspection capability.
So one of the things that comes to mind, Bruce, is you've been doing this a long time.
Yeah.
And what's neat about you is, like, for example, myself in my career, all I've done is ILI my professional career, right? But very little of it was tied to research, where we really understood the physics behind how some of these tools work. And you have that background. You were able to do that. And in the 30 plus years, the technology's changed a lot, right? We hear things like what's communicated to us, and that's why I want to get your point out, right? We hear things like we have triaxial sensors now. We have ultra high resolution tools.
Ultra high.
Yeah. We had this conversation. What's after ultra?
Nano.
No, it's
nanotech. Micron. Then it'll be nano.
Then it'll be nano.
So if there are any people out there looking to invest, Christopher and I will be starting an ILI company calling it Nano MFL.
That's a joke.
That's a joke.
That, but I'll go back to what I said and got in a huge amount of trouble.
Okay.
At a pigging conference.
He's about to get in trouble.
All right. Bomb number 1, here it comes. Audience, brace yourself.
So I got asked the question. This is back in the early 1990s, and this is when the sensors were going from paddle sensors about 6 inches across to sensors that were maybe a half inch, maybe an inch. They were really coming down in size. Now they're down to, it's about a 1/16 of an inch, is these nano ones.
Yeah.
And somebody asked me, well, what's the definition? They were talking about these high resolution pigs. Now it's an ultra resolution pig.
Yep.
And now you're talking about, what's the one you call it?
Triaxials.
No, nano.
Micron.
Micron. Is that the
Yeah.
one you're calling? And the guy asked me, what's your definition of that? And I said, it depends on the smallest defect. You need the size.
Mm-hmm.
You know, I don't. If you're trying to, again, measure something the size of your hand, you don't need sensors more than about every half inch around the circumference of the pipe. If you go the other direction, if you're trying to do what they call pinholes in the industry is something the size your pinky can go in a pinhole.
Yeah.
That's not. So if you need that, you still need to get at least 3, maybe 5 sensors across any defect. And that is what a high resolution tool is. If you need to size something smaller, whatever the smallest feature you need to size,
You need 3
just
to 5
need 3 to 5
sensors.
sensors smaller than that to be able to size it.
I like that.
That's all it is.
Now-
And he's saying, oh, this is new stuff. It's not new. It's just now.
So he who has more sensors wins.
Not necessarily. Hey, you want to look at all that data?
All right, Bruce, I have one question. Do you have opinions on other things like, I don't know, maybe RSTRENG and tool specifications?
No, probably.
All right. Well, audience, I want you to hang on. We are going to take a break. Come right back with us because I suspect in addition to 3 to 5 sensors across the defect, Mr. Nestleroth probably has some opinions on other things you might be interested too. Hang on, we'll be right back. All right, welcome back from the break on this episode of Pipeline Things. So a couple of things that you missed. See, audience, you don't ever get to see what happens behind the scenes in the break.
Yeah.
But I want y'all to feel like you're a part of the show. So 3.0 has fully assumed the role of producer, and I gave her some feedback on how she gives me break warnings, and she said, point blank, this is how I produce the show. So now that I know my role as simply a cast member,
Stay in your lane, bro.
stay in my lane. You may see me from time to time ask 3.0 for guidance on how we should do things. But no, seriously, she's doing a great job. The other interesting thing is, again, you might hear some noises in the background. That's because today we're filming. This is actually the second time we filmed from Fiesta in Guadalajara. Thank you to that restaurant for the venue and also for a fantastic lunch. If you're ever in,
That's great.
if you're ever in town in Houston, Fiesta in Guadalajara, highly recommend it. But we left Bruce, after we introduced Bruce, one of the things we didn't highlight enough is that if you want the opportunity to spend time with Mr. Nestleroth, that comes at least once a year through the form, or twice a year?
Once a year. But
Once a year. There's others too, but you're who we're after today.
Well, I'm gonna take a step back again because I like to go back. When I got after that MFL report was written, they said, well, let's do a workshop. Now everybody goes to workshops now, right? The PPIM has.
You can call anything a workshop these days.
They're all over the place. In '95, there was nothing. There wasn't a workshop on anything.
Yeah, so you couldn't learn.
There was no learning things. You could get some of the papers that were published.
So you were like, this is a great opportunity to break one.
Well, I wasn't me. That was somebody else came up with the idea. But I got to do that, and I got to admit, the first one I did, it sucked. Listen, you didn't say that.
Might be like our first podcast. No, you're absolutely allowed to say
They
it.
had PowerPoint back then, didn't they?
No, it was freelance.
Oh, okay.
Well, we're getting there. WordPerfect, Lotus 1, 2, 3.
Okay. WordPerfect. I remember WordPerfect.
There we go. Well, and then what I was forced to do was that by the GRI, the people who were funding it said, you got to get somebody with some experience. And luckily, Pytronics had just gotten sold, and they were down. A few people were left in Toronto.
Is this where Fraser Farmer comes in?
That's where Fraser Farmer, and he set me down the line. And for that workshop still goes on. I know that there is a punchline at the end of the story. We still do this workshop today for the Southern Gas Association. It's actually at the end of April this year. It's not just me. I only talk about it's a 3.5 day class. I talk about 1 day of it, but we bring in other people to talk about everything about that you need to know: how to do the defect assessment, How do you do ultrasonic inspection? How do you do?
It is a great course. I have taken it.
took it.
Christopher has taken it.
That's how-
We're sending some of D2's employees to take it. It
that's
is
how
a
I-
highly recommended course
That's
for our
how I'm at
audience.
Fraser. That's what I remember.
Yeah, but that's not the only way to get there. I mean, I tend not to do an awful lot of workshops directly. Currently working for Rosen, going to be, but basically as an independent contractor.
Sure.
And what I do is I do direct. If your company wants to learn about these things, I really like to do workshops on a company by company basis where you feel free to ask questions. You get in a room.
So you can
full
tell them
of
the
people.
real answer is what you're saying.
I can.
So you can get the low down and the dirt.
Bruce Unplugged.
Yeah. Maybe we can unpack some of that today.
And I think that's so much better than things, and that's what I have done. The other thing I do is, if you need some background information, some good basic stuff, I actually think it's all these workshops you kind of get a repeat after repeat of the same information. And I think it's just as good to get your background information off the Rosen Competence Club website. They have a lot of stuff that's online. You can spend an hour at your leisure. Pick up a little bit on this topic, a little bit more on this topic. Get your fundamentals, and then as I said, if you can get people, and I think other companies other than Rosen do provide technical training if you ask for it. But they will give you. They get the nitty gritty, the dirt, the hard parts.
You bring up a really good topic here, right? Which is I appreciate the theme of reach out and ask for help, right? I mean, that's kind of a theme that we advocate on our podcast all the time, right? In our form is phone calls are free, right? We also often say get out and read and reach out and understand what papers are being published, right? What work is being done, whether it's industry organizations or research like PRCI. Obviously, Bruce is saying, there's a lot of good information out there from ILI vendors. Yeah, get educated, right? I mean, one of the things that I presented, you and I actually talked about a topic over lunch, which was, true ILI capabilities, right? And a lot of times, maybe people making decisions don't have the opportunity to do the homework, or they may not know that there is help out there to help them understand what tools can actually do, right?
Yeah, and I mean, I find the industry has a lot of almost sort of wishful thinking of what they just hope it can do what they need it to do.
All right, let's cut straight to the chase. All right, Bruce, best questions that you have been asked in your course
Over 30 years.
Because I know
95, 24 is almost 30 years.
I'll lead you, because now we've taken so much time enjoying conversation with you. We can't go through all of them. But that's why I say people should come see you. That way they can ask you these in person, even their own. How should people understand specifications for ILI tools?
Well, one of the things, I think specifications are important. In that if the first thing when you're trying to understand the specification is that you don't read, they all read about the same. What you really want to pay attention to are the footnotes, and that tells you what the tool can't do, because that's where it's not what everybody looks at, it can do plus or minus 10%. And then you see, with an 80% certainty. And it has to be this wide, and it has to be this long, and it has to do this, and it has to do that. And that's where you're going to get into it and figure out, and that's how you can get a little bit away from your wishful thinking and saying, there are a lot of problems with trying to get this to work in that way. And the second thing I hate about specification, and I think it's probably where I talk about.
It was a loaded question.
To talk about first is one of my favorite
Tell us what
things
you really think.
is that it's statistically impossible for all ILI tools to have the same statistical performance. They all say they can do plus or minus 10% with an 80% certainty.
Why is that impossible, Bruce?
Because everybody's tool isn't going to work the same. There's some going to be better and there's some going to be worse, but they all say they do the same.
Why?
I think it's the guys who can do it better are afraid they're going to get it wrong. The guys who can't do it at all figure they aren't going to get any business.
They hide in the crowd.
They have to
Herd mentality. That's what I heard.
They all gravitate to the same number. But it's your job as a good pipeline operator is to figure out who actually can get close to that specification. Which of the guys actually can do the job? Because in the end, it's your pipeline. If it goes boom in the middle of the night, they aren't calling the pipeline.
So you just said, you mean the vendors. They're not calling the vendors. So
I'm sorry.
you're telling me that operators should perform due diligence on making sure that vendors can meet their specifications, not just trusting them.
I think so.
Yeah. So it's valid. I mean, we advocate this. In fact, and don't know
But
how
most
great I'm
people-
doing presenting on this, but that's exactly what the topic is for a particular paper that I'll be presenting this year at PPIM, right? Is it's API 1163 has some guidelines in there that I feel like often in practice.
But
get
haven't we
overlooked,
been
right?
around, Bruce? I mean, you've been doing this for 30 years. Hasn't MFL been around long enough? I mean, doesn't it work?
No. It doesn't always work.
It does work. It just
It
works
works.
under certain conditions.
It does do a very good job. I mean, it wouldn't still be around if it didn't solve
True.
some problems. And if it wasn't solving exactly that, but the trouble is it's not perfect. I think that's the difficulty is, and the imperfections. You still got to live with it.
Do you think we get so comfortable with the technology because we've been around it so long that we maybe forget which questions we should ask or take granted?
I think each generation that comes by always asks the same, what I refer to dumb questions over and over again. Because can it do that? I go, no, it really can't. It just you can't get that from what direction you're going. But because it works occasionally quite well, and under certain conditions. But there are geometries, there's speeds, there's.
Do you ever get in fights with the ILI salespeople?
No.
Really? I would like to put you in a room with a whole bunch of the ILI salespeople.
Oh no, I don't think I have any. I haven't. I have good friends who are that. They know that I understand it.
I'm joking, Bruce.
I think they understand that they're not, but
They have different objectives.
They have different
Bruce and the
objectives.
ILS sales team have different- But hold on, we do need to backtrack a little bit, right? So MFL technologies do a fantastic job.
They absolutely do.
they solve a lot of good.
There's a reason they're the
and,
favorite child.
Yes, and
It's a-
that's exactly right. It just boils down to you need to ask the right questions.
That is correct.
Right? So we said it earlier, just backtracking, right? If you're looking for something that's this big, you need to have at least 3 to 5 sensors that can detect it so they can do a good job. If we have references, for example, the POF dimension classes that say if you're looking for a specific morphology, make sure the tool has the ability to do that. What you're saying is but you need to be considerate for orientation, right? Maybe an axial tool will have some limitations for some flaws. Maybe you do need a low field or some other sensor to augment the analysis, etc.
Yeah, there's a million flavors of MFL, and you got to pick the right one that fits the job.
Yep.
It's not you can't be using a Phillips head screwdriver to bust up a rock.
So let me make. How do you?
Hold on, can you imagine if we started naming ILI tools like, oh, that's the Rocky Road? Be like, oh, that's the Neapolitan flavor.
Oh my gosh. So I want to make this real because one of the things that we try to do with the Sage series is help younger engineers. What advice do you? So when you say, that they need to validate or ask the right questions. How does an engineer who's maybe not as familiar, maybe it's their first MFL run, maybe it's with a new vendor, what do they need to be doing? I mean, what are you advocating that they should be doing?
Besides taking good workshops and trying to get ones that when I talk about MFL, it's a 4-hour marathon. If you had a class that gave you a 1-hour introduction to MFL, you have not gotten deep enough. If you take that's true for ultrasonic one. If you try to ultrasonic wall thickness, that's not such a big thing. But any of the either ultrasonic crack detection tools or the EMAT tools, if they're not talking 2 to 3, 4 hours about it, you aren't going deep enough. You're just scratching the surface, and you're just saying, well, it's the happy solution. It's going to work, and they'll tell you all the situations that'll work, and that's not the problem. It's not the smallest defect you can find. It's the biggest defect you're going to miss. That's what you have to do is figure out what am I going to miss with this tool
on each pipeline, because each pipeline is different, right? And each pipeline has its own threats.
And it's fair to say that the course, and you're not answering the question directly, but you're answering it the right way, which is you really have to get enough information about the technology to know what questions to ask and to know what you might miss.
And one of the things that we'll advocate is, we worked at, particularly a bit longer than you, was each technology company has a different measurement principle on which their ILI system is based. And it is very important for you to talk to that vendor to understand what that is. And it is important. There's some material out there, but it's not consolidated. And that's why we say phone a friend, call for help. Talk to all the vendors and ask them what makes them different, right? So all the sales teams have what's called unique selling points, right? USPs. Ask them what they are. And then build your little matrix out and find out who does what. Like some tools are triaxial sensors. Maybe Bruce, at some point when you buy him a beer, he'll tell you why that matters. Why some tools have a low field or a residual field and how that may or may not help, right? Why does one MFL tool say they can do pipe grade and all the other ones say they can't, right? It's important to begin to ask all of these questions so that you can understand if you have this Batman utility belt. You know, I love Batman. For each threat or each challenge, you know which tool you need to pull out.
Or you could just A, attend his workshop, or B, hire him to do your own workshop for you as an operator where you can ask him
and
all
make him
of
a
these
list. He'll make you a 20 questions list for each highlight.
And if you do manage to stump him on a question, please send it to us, and we'll come up with Bruce's list of stumped questions.
Podcast number 2, right?
That will come back.
So I do have a question because I want to feel a little bit validated here. Right? So we had a podcast on this already.
You two have a shared mutual point of contention.
Yep. And I presented it at PPIM last year. So Bruce, how do I want to ask this? I want to be polite about it.
No, don't be, please.
Can MFL do a good job at calculating R-string based burst pressure calculations?
Chris, we already answered this question. It's yes. Why are you asking it again?
No.
1 point CDL, baby.
It doesn't, MFL can only measure 2 things. It measures depth and length of a corrosion anomaly. It does not have any ability to give a river bottom through that entire corrosion area. It just does length and width.
Bruce, I have an ILI final report pipe tally on my possession right now that has a column.
There is a column
labeled R-string.
I understand. I've seen it too. And when I present this section of my workshop, I show that column because I get there, and I have had people have come up to me and said, no, the new tools can do it now. You're just out of date.
Wow, they aged you? Wow, they dated you?
That hurt.
Wow.
Did you ask them to go outside?
Well, they said, no, they can do it. And it doesn't do it. It does a kind of a piecewise R-strain. If you have a bunch of pits in a general location, it can do R-strain based off the depth and length of each of those individual pits, and because they're clustered together. And I know I'm talking a lot with my hands, and it's really confusing, but it's not going through there and measuring a river bottom. It's not going to the deepest point. It's just kind of piecewising it out through the deepest point in any corrosion area. And if you have 5 or 6 together, then it gives you an R-strain number.
I'm going to ask you a super loaded question.
Uh-oh.
And we're getting really close to wrap up time. If you were an operator, would you use the values in R-string in your final reports?
From MFL? No. I don't think it provides anything more than
the modified B31G.
B31G equation does. It's essentially.
Do you say that in your workshops?
Yeah.
Fantastic.
And I don't think many people do in their workshops, but I do.
Wow.
Because
there are ways.
Chris, there you go. You got what you want.
I know.
You got what you want out of the whole episode.
Yeah. And the other thing I'll say is that is not my point. If you guys have heard me speak about this at least once, I always say, work with your RLI vendor, right? Understand their process, understand what they're doing, and understand how their method was validated. And then once you go through that process, you can begin to make a decision as to how you can use it, if you should use it, or if you want to create a process with your vendor by which you expect them to go through before they provide you that calculation.
So, Christopher, Bruce, 3.0 is flashing signs at me. I don't know if that's the stop sign, if that's a gang sign. I'm not really sure actually what's going on. I think she's giving me the wrap-up signal. But what I want to give you any parting thoughts, anything you'd like to say. I want to say I have thoroughly enjoyed having you on. Yes. Thank you so much. You have the floor. What would you like to say? Any parting thoughts on MFL or your career or the pipeline industry? It's broad. I'll leave it broad.
Oh,
once you start, you never get out. It's like the Lotus Lounge.
Oh, I understand that one. I guess my favorite one, and I have sayings that go through there. I have, Tom Bubenik, who I still teach classes with, I was told he was quoting me yesterday. He was doing some of my favorite ones, and one of my all-time favorites is, don't expect an MFL tool or any ILI tool, that fact, to be able to give you measurements at 5 miles an hour that you can't do in a ditch in an hour. If you can't get in the ditch, and it's hard to make even corrosion measurements in less than an hour. When you go past the defect the size of your hand, you got 1/10 of a second. 1/10 of a second. That's all you get to collect all the information. And you're going to be sitting out there, the pipe's kind of round, and
they'll put the little dots for the creaform, right? They put the dots all over the pipe.
Pipe's wavy, and pipes, everybody seems a nice cylinder. It's not cylinder.
It's full of crap on the inside sometimes.
Here's one of my parting thoughts with Bruce. So obviously we talk to our guests before we shoot, and it's not verbatim, but I might have to use this in my PPI presentation. That it's already published since we've aired this, but it was, nothing is foolproof for a sufficiently talented fool.
Wow. All right. On that note, I think 3.0 is going to turn the camera off. But I just want to say, Bruce, thank you so much for joining us. I feel like we need to have you on again sometime to cover the rest of the questions that we can't get to. But thank you for joining us on the Sage series.
Thanks for inviting me. This was a hoot.
I'm glad you enjoyed it. Really, congratulations to 3.0 on her first successful production solo of the podcast. And we'll see you in 2 weeks on the next episode of Pipeline Things. Thanks for joining us.